we're going to measure again today. But today is going to be a little different. Last class, we talked about 12 inches equals a foot. I just gave you the first one. 12 inches equals a foot. All right? Now, how many feet equal a yard? Yes, Rachel. Good. 3 feet equals 1 yard. Is there anything in the room now that we can show that 3 feet equals a yard? Anything? Natalie, what do you think? Is there anything in this room, maybe even on your desk, that we can say 3 feet equals 1 yard? A yardstick. But how many inches are on that yardstick?
How many inches? 36.
36. So put it in a full sentence for me. What can you tell me about inches and yards?
A yard equals exactly 36 inches.
Good job. 1 yard equals exactly 36 inches. This is a big number, guys. Pablo, read this number for me.
5,280.
5,280, what? What is our unit of measure? Feet. Equals to what, Aramis?
1 mile.
1 mile. Awesome. You remembered everything we talked about. Great job. Now, we have a big one here. Read it to me.
3 feet.
3 feet equals what?
36 inches.
36 inches. Awesome job. But can you tell me how you got that answer? I believe you, but I need you to prove it to me.
I multiplied 12 with 3.
Okay. You multiplied 12 with 3. Why do you think he multiplied 12 with 3? Why could we not pick 18 or 24? Why 12?
Since 1 foot equals 12 inches, then we want us to tell you 3 feet. So we multiplied 12 times 3.
So you multiply 12 times 3. That's a good answer. Let's give him one clap. Good job. Now, I have another question for you. I have 2 pencils here. I want you to tell me which one is longer, the red one or the purple one. Yes. The purple one? What did you think, Rachel? The purple? The purple. The purple is winning.
To tell which one is longer, I think you should put both of them right next to each other and to see which one is longer.
Why?
Because, for example, if you take this one and this one, you can't really tell if it's different. So you have to put them like this and see which one is longer.
I need to put them together. So what is this called? I'm doing what?
Measurement.
Okay, I'm measuring, but what am I doing? I'm comparing. Awesome job. I'm comparing the two to see which one is longer. Was our guess correct?
Yes.
The purple one is longer. When we're measuring something that's not straight, what happens when we're trying to measure something that is all twisted and turned around? What do we do then? We're going to figure it out. Let's look at this. All right? Now, we have a line here, and we have a curved line here. I see your hand. You're waving at me. Hi. Talk to me. What are you going to tell me? I didn't even ask a question. What are you going to tell me?
I think I know how you can probably measure it. You can probably measure it from the middle with a yardstick or a ruler, and it'll practically show you how big it is.
It'll practically show me how big it is. So she's saying I can measure it with a yardstick or a ruler. But I want you to show me, because you're telling me I can measure this semicircle with that yardstick. Can you come show me? I want you to show me how to measure a semicircle with a yardstick.
You can probably go like that.
But am I measuring this? Talk to me. Not really? Okay. Can I measure the straight line with the yardstick?
Yeah.
Okay, and what is it? What is the unit of measure on this?
Where is it?
Okay, let's turn it to inches. Measure it again. How many inches?
Like 15 and a half.
Like 15 and a half. So if this is 15 and a half, are you telling me this is also 15 and a half?
Its width is.
The width. Oh, you're using big words. Thank you. Let's have a seat. Thank you. We're going to get some more ideas. She says the width is. I like mathlish. Those are the math terms. In math class, we speak mathlish. That's the language that we speak. Okay? So she said the width, but I'm not looking for the width right now. What is it that I am looking for, Kristen? The length. Awesome. How do we spell that, guys? How do we spell it? Length. Okay? So I'm trying to find the length. All right? We said we can't use the yardstick. It was a great idea, though. We got half of it. But what would you suggest?
I think we use a protractor.
You think we can use a protractor on this big semicircle right here? You think so? Okay, any more ideas?
Maybe you could measure this side, then measure this side, then measure this side and this side, and then add all the numbers together and it'll tell you.
Oh, that's some good thinking. But is that going to work? Maybe. Okay. Yes.
We can have another idea.
Okay. All right.
Like how he said, we can. This again is 15 and a half. Maybe we can measure from here to here, and we can add it.
But that's what one of your classmates said, right?
Yes.
That's what she said. That's what she
No.
said.
She said going like this. What I meant was like this, measure, and then measure the here to here,
Okay.
and then you can add it.
And then we can add it. Okay. What if this did not exist? You can take it back to your table with you, please. If this did not exist, we didn't have a ruler. We don't have a yardstick. The ruler and yardstick monster came and took them all away. I'm still stuck with my problem. I still don't know what to do. I still haven't figured out which one is longer. All right? What I want you to do while you're sitting right here at your tables, amongst your table mates, discuss it. Figure out how would you know which one of these is longer. And then one person is going to report to me. One person is going to let me know what your team thinks. Okay? The best strategy or the best way to figure out which one of these lines is the longest. Do we understand the instruction? The students need to take ownership and figure it out for themselves. They used the tools that they felt were the best for the activity. They were given pencils, string, yardsticks, all those things were made available to them. However, there was no right or wrong tool to use. So I left it up to them in order to figure it out. And once they figured out which tool worked best for them, then I just supported them in that decision and allowed them to make their own decisions.
We can just use the string and measure it, or put the tip of your nail to your first quarter of your knuckle. That's an inch, so then we can measure it like that. Or we could just measure it with the string. So it would be one, like numbers to it, make it like a protractor. Yeah. Two. Look at the string. Like, imagine this is the bottom line, right there. And then if it was a string, and then if we were straightening it out, the top one would be longer. Use a string.
All right, let's bring our thoughts back in. 5, 4, 3, 2, 1. All right? Natalie, report for your table. Report for table 2. What do you guys think?
We thought maybe like, since like your knuckle is probably about an inch.
Okay.
You can take that and go around.
You could take it and go around.
Or you can measure about how long a pencil is and take it around.
Okay. Awesome idea. One clap for Natalie. Now, This is what we will call non-customary units of measure. Why do you think I would say non-customary? Non-customary. Chloe? Huh?
Because you can't measure it like a straight line.
Okay, so what is a customary unit of measure then? If we said customary, what is customary?
Like what you use all the time, like feet, inches, centimeters, meters, kilometers, miles.
Right, things that we're used to using, things that we can pick up a ruler and measure it. So non-customary is
It's not equivalent.
not equivalent. Equivalent is good mathlish, but that's not the word I'm looking for. Yes.
Something that you can't really measure.
Something that we normally wouldn't use to measure, right? Have you ever seen your parents when they're trying to measure how many feet something is and they walk like this? And they try to measure? And they say, well, it's feet, so let's measure, right? But what happens if your mom has a size 7 foot and she's trying to measure feet? Would that necessarily work? No. Why? If her foot is 7 inches long and she's measuring how many feet it is from here to here and she's going to walk, is that going to work?
No.
Why? Yes.
Because her foot is 7 inches, so it's not exactly 1 foot. Because a foot is 12 inches, so she would need her foot to be 12 inches.
Okay. So we would need for her foot to be 12 inches. A big foot. Shh, don't talk about big feet. All right? What I need everyone to do very quickly, and listen up carefully because we're going to do an activity, but I need to give instructions all at the same time. All right, so what we're going to do is move to the station table. All right, everyone come around at the station table, and I'll give you instructions back here. All right. Is this a straight line?
No.
No. All right, can I pull out a ruler and measure this?
No.
No, it's not going to work, right? All right, so what we're going to do is we're going to take our recording sheets. We're going to take one, pass it around, make sure everyone gets one. Make sure everyone gets one.
You guys aren't taking any.
Everyone has a recording sheet. Everyone should have a recording sheet. Okay, I'm going to put this over here. All right, so we have one station here where we're standing. The other one is at table 3. Okay, it's at table 3. What we are going to do is we are going to try to decide which one of these is longer. Okay, we do not have a ruler. We cannot use our yardstick. But we want to figure out which one is longer. If you want to use a yardstick, hey, go for it. I don't care. I want you to figure it out, okay? Your task is to decide which one is longer. But before you begin, you have to make a hypothesis or a conjecture. Do you know what a hypothesis is?
Yes.
What?
Your guess. An educated guess.
An educated guess. And we hear that a lot in science, right? Yeah. Okay, but in math, I will call it a conjecture, all right? What we think is going to happen. So you're going to put an X on which one or which one of these shapes you actually think is going to be the longest, okay? When you get back to your table, you're going to put an X on that shape, okay? Then you're going to break into groups, and we are going to come to the table and actually try it and actually see what we think. And we're going to figure it out, all right? But it's going to take talking. It's going to take strategizing. It's going to take planning. All right, guys? Does everyone understand?
Yes.
All right, let's go back to our tables with our pencils and make our conjectures, okay? The students were engaged the entire time because they were able to work as teams and work in groups and go between each table or each station to try to find the largest measurement, I guess, or to find out which one was the longest or shortest of the 2 paths that we gave them. These students, they had one conjecture, they had one thought in mind when they started out. And because we had done the lesson previously, they knew they were right. They were very confident in their answer until they actually had to figure it out on their own without my assistance. They had my assistance in lessons previously. This time they were on their own.
Inches.
Sorry.
28 and a
A
half.
little bit longer.
28 and a half. 36 and a half. 3 quarters.
That's 28.
2 quarters?
Okay.
36 and 3 quarters. Where?
So now after
Which
that.
bigger? No, it's more like 28 and a half.
Okay, why did you all decide to use the yardstick? Why did you decide to use the yardstick?
Because this one is
Because
this one has
this
straight
one's
lines
straight.
and that one has
That
like
one
a
is
bunch of
all
curves.
Okay.
And I got I know how long.
Okay, so
Okay, don't
here,
tell me. I don't want to know
here
yet.
is
I'm just trying to want. I wonder why you chose
and a
that.
half,
Yes.
I'm pretty sure I
and a half, and a half, and 2 quarters.
So then I guess.
Yes.
So then we
Ours is 36 and 2 quarters.
From here to here? It's 36 and 2/4? How did you figure that out, though? How do you know?
We put the yarn from the tip here, and then we colored it with a blue marker. And over there, she colored it with the blue marker too on the very last tip. And we measured it after that, and we saw that it's 36 and 2/4.
Okay. The question is, how long is this? I want to know how long is this entire figure. That's what I want to know. Okay.
We're supposed to do it curved. Just curve it. Curve the tip. Put it on the tip.
Work it out together.
Color it on the tip. Tip.
No, over
tip.
here.
Tip. Yeah.
No, right here.
Okay, you changed your strategy, right? Yeah. Tell me why we changed. What did we change to? Tell me your thinking.
We put the yarn all over that, and then we painted it on the tips, how long that was, and now we're gonna measure it to see how long it is.
And the type of questions that we ask are leading questions. I don't want to tell you the answer, but I do want to help you to get to where we need to be. So those type of questions that I ask, for example, say, well, how did you get that? Or did you think about this? Or why did you choose to use this instead of that? And those type of questions, even if they're not sure, made them think a little bit more. Well, I'm using the string because, and they had to think, why am I using the string? Am I using the string because my teammate said, let's pull out the string? I want you to know why you're doing it. And so I ask questions to make them think about why you are making the decisions you're making. All right, let's go back to our tables. Chloe, let's go back to your table, sweetie. I'll give it to Pablo. Rachel, have a seat. Thank you, Pablo. Here's your paper. All right, let's go. Everyone is back in the seat. On the bottom of our paper, there is a blank spot. If you want to use it, you used it for work, so you're going to draw on the back. All right, but I want you to draw me a picture of how you solved it, how you solved the problem. If you use the string, we can draw the little string. If you use the ruler, try to draw the ruler. But I want to see it. Because if I wasn't here and I walked in and I pulled these papers out of your student folders, I want to know, how did this student solve the problem? All right? So just take a minute and do a little sketch for me on how you solved the problem. And then we're going to discuss it. We're going to put our thoughts now into a drawing and then into words. All right? Because I want you to talk to me and tell me exactly what you did in your group. All right, we're going to share our ideas. We're going to share, we're going to talk. I see your hand, Jules. You ready? With this activity, the only thing that I would do differently, or not even differently, but in addition to it, is show the students how they would use this in the real world. Now that we've measured the paths on the tables, we've measured the paths before, how does this apply when I leave this classroom? How does this apply when I walk out of those doors? So sometimes we need to walk outside of the classroom and go outside and let's measure a path. The same way, without a ruler, without any measuring tools. How would I use this outside of the classroom? So as far as this activity is concerned, that is the only thing that I would add to it, is to show the students how to apply this technique in the real world.